Please join me in welcoming Robert Matusewicz.
Thank you for introducing me, Dan. Thank you for showing up my presentation. You are very special. During my software engineering career, I never worked with a team that implemented a new business feature, delivered that business feature to production, and done that without introducing new bugs into the product. I know that's trivial, but teams are built from people, and every person, no matter how smart or stupid it is, sooner or later will make a mistake, and this mistake may end up as a bug on production. Sometimes those mistakes are caught early at the point of the code review, when one developer is checking the other developer code before pushing the code to the trunk or master to check if there's nothing smelly with it. The next line of defense are various kinds of automated tests. So unit tests, integration tests, functional tests, system tests, or any kind of automated test you are using in your company to check that the code you are pushing to production is valid. In many companies that I work with, the last line of defense are manual tests performed by the testers. So the manual testers can, for example, do some regression checking or security checking that are too costly to automate. And yet, even if we have all those defense mechanisms set up, some bugs are some kind able to reach the production. Some bugs are so nasty, vicious, and devious that they will beat any mechanism that is designed to catch them before releasing product to the production. Sooner or later, each such bug will be observed by the client and reported. The bug will go through the painstaking way from a bug triage process to the product owner that is responsible for buggy functionality, and then to the team that implemented the functionality where it be analyzed and fixed. When one of such bugs is delivered to my team, usually I'm one of the first person that start analyzing it and breaking it down into prime factor. And I'm not doing it because I'm forced to do it, but I also like to do it. Analyzing the bugs that somehow were able to reach the production is very satisfying to me and give me enormous possibilities. I can see and understand why current testing and quality management strategies failed, and if I understand those reasons, I can propose a new defense mechanism to prevent those things happening in the future. This defense mechanism may be as easy as adding a new automated tests or new monitoring tool, or a little bit more complicated, like changing the process that failed. During this presentation, I would like to tell you a few stories about bugs that frustrated and confused people in my company, but also allowed us to learn how to design and release better and safer product. The first story I would like to share with you is about how uncontrolled system update causes a lot of pain. After that, I will try to tell you about how we are handling date and times in our system and why we're doing that in a wrong way. And at the end, I try to tell you a story about how not understanding the dependency injection technique can cause a lot of memory leaks in your system and a lot of CPU overusage. When I was preparing that presentation, a few colleagues asked me, but why do you want to share our failure stories instead of our success stories? Do you want people laugh at us, or do you want to scare them or discourage them to contact us? And of course not. It's not the point of this presentation to laugh from people I work on a daily basis. The point of this presentation is to share failure stories because I strongly believe that they have the biggest opportunity to learn. I know that success stories are pretty cool, but lessons are usually hidden in our failures. Say that there is one legal notice that I need to make here. More than one person was involved in investigation of each bug that I will present here. Sometimes I was the part of the group that was investigating the issue, but sometimes I was not and just bastarded and stole the investigation result to present them on my presentation. But do not worry, every key contributor of the investigation agreed to that, and they are mentioned on the last slide of that presentation. One of the hardest things I encountered when I was preparing this presentation was the question, how should I start? I knew I needed a great example to catch your attention, And I also wanted to show you something representative that will show you that even if you implement good practice within your team and your company, and even if you don't do anything that is described as a malpractice, even then something may go wrong and you will end up with a broken service or feature on production. After a long time of thinking, I recalled one of the stop the line emails we received in our company a few weeks ago. And if you don't know what the stop the line is, it's one of the Kanban practices that is implemented in newest media. It usually happens when there is a bug on production or in our system that one person is not able to solve, and we are close to hitting a deadline because, for example, we promised to deliver some specific feature to some customer within that week. And when stop the lines happens, it's call to arms. It says that everyone should stop doing what he or she is doing and should do everything that is in his power to help solve the problem and release the product as fast as possible. So back to the core of the story. In our product, we have a lot of statistics that help managers to judge how busy their agents are. And one of that feature is a web page that displays a real-time statistics of how many calls are waiting in a queue to be delivered to the agent, how many calls were abandoned, which means that the client got tired waiting and decided to disconnect the call, and how many calls were handled successfully. And in this stop the line mail, one of the testers said that this feature is not working. Or maybe not working is not the best word because it was working, but instead of refreshing the data in real time, it refreshed the data only when the user hit the reload button. So it's not a very user-friendly behavior because nowadays in 21st century, when we look at the real-time statistics, we all expect that those statistics will refresh when the data change and not when we hit the refresh button. And the fact that those data was only refreshing when we reloaded the page allowed us to narrow down the issue to the page or to the web server that was hosting the web page or to the database that was storing the cache statistic that should be presented to the client. After some time, we found a very interesting code that we thought the problem is with that code. We suspected that method because it was responsible for presenting the data that was not refreshing on a client side and was also using a cache, so a mechanism that when misbehaving can cause a problem that we observe on the production. And if you look closely at this method, you will see that one of the key responsibilities of that method is that it takes a user identification and account ID to which the user belongs, then try to check in cache that the statistics for that user exist, and if it exists, it will return that statistic to the client, and if it doesn't exist in the cache, it will read to the database through the repository, fetch the data from the database, store the data in the cache, and then return that data to the caller. We assumed that the problem may be with that code and decided to dig deeper into the implementation of that cache. We found out that this is the synchronous memory cache that is used by all the services within one web server, but different services use different caches. And if you see at the code, it has two main responsibilities. The first responsibility is to place the item in the cache, so we don't need to ask a database each time the user requests it. But the second responsibility is also setting the expiration of that cache. When this method will pick an absolute cache expiration policy, it means that the item will be erased from cache after some time, and it doesn't matter if that item was used or not used. If this method will pick a sliding expiration policy, it will mean that the cache will remove the item from it after some specified time, but only when that item was not used during that time. And we concluded that this behavior that we saw in production might be caused by wrongly setting either the time on the cache or the expiration policy of that cache. But we also done a git blame on that code and the code that is using that cache. and notice that it is not changed since ages. So we kind of have a suspect that might be a cause of our problem, but doesn't have idea how we can prove that this is really a cause of that problem, because no one was changing the code since ages, and this code stopped working just now. After some time, our whole investigation was invalidated by the testers. They noticed that the bug happens only in one environment, even that we have other environments on which we installed exactly the same version of the software, but on those environments everything is working correctly. And this was quite good information for us, because now we could assume that the problem is not related to the code, but it is related to the environment. So we decided to look at the environments that are faulty and that on the environments that are working, and compare configuration files. Unfortunately, when we compared the configuration files, we concluded that they are exactly the same of each of the environments. So we then decided to look at the installed software on the faulty environment and installed software on working environments. And that was a good choice, because we noticed that on a working environments we have a .NET Framework 4.6 installed, and on the faulty environments we have .NET Framework 4.7 installed. So one of us asked that question: could it be that we somehow allowed to update the .NET Framework on a faulty environment, and this broke the cache? We wrote an integration test that checked the behavior of the cache on what version of the framework, and it was true that on the 4.7 version of the framework the cache is misbehaving. After some time we noticed that the community already knows what is the problem, and the problem was that when you are using some particular overload of the cache insert method, the runtime of the .NET Framework will either expire the cache too early, too late, or it wouldn't expire the cache at all. They fixed the problem soon after they discovered it, but it was too late for us, because we somehow allowed for unscheduled update of the system in our environments. And of course, during this investigation, we learned few important things. The first thing is that it's not always the problem with the code. Even in the culture of work, when you are delivering the software to production twice a week or twice a day, or maybe you are delivering the software on demand, as soon as you will hit the bug on production, you need to rule out the environment cause as soon as possible. Because if you don't do that, then you will waste your time trying to find a ghost in an environment when the problem is in the code, or trying to find the problem in the code when the problem is in the environment. The second important lesson for us was that we need to have a policy that controls what we are updating, when we apply those updates, and why we are doing that. In our company, we're still in a transition from the virtual boxes to the Docker, but even if you use a fully Dockerized environment, you still need a policy to, for example, check if a change in entry on DNS won't cause you a problem, or change of entry in a load balancer will direct traffic to those Docker containers you really want. But the most important lesson for me as a programmer is that you need to integrate your code with respect to the framework and the libraries you are using. I know that this is not a very common not a very common practice, because we somehow trust the external providers that they will provide a library to us that is working as we are expecting. But as you can see from that example, even so big company as Microsoft can from time to time deliver a framework that is not working and can break your code. And in that situation, the integration tests are a lifesaver for you. The next story I would like to tell you is about time, or to be more specific, about time, dates, and MySQL storage engine. But before we dig into the details, let's imagine that we are all in the beach on Australia. It's late night, and we're drinking a wine and watching the stars, because stars in Australia are pretty nice. And after some time, around 2 a.m. in the morning, you notice that your bottle of wine is empty, and you decide to call for a taxi to order more of it. You pick up your phone, dial the taxi number, and wait till connection will be established. Wait 1 second, 5 seconds, 10 seconds, and nothing happens. And nothing happened because accidentally during the same time there was a time zone change in Australia and all the connections dropped. They dropped because BTS provider didn't care to implement the change of time zones properly in their code because they thought that it's not a problem when the time zone happens. And it's so true for so many companies. In all the companies I previously worked, there always was a problem with handling a code that is responsible for changing the time zones. The previous story I shared is from one of my previous employees, that the name I cannot share. But if you're smart enough, you can always look at LinkedIn profile and figure it out by yourself. But in US media, we also have some pretty nasty stories that are related to time zones, and that also caused a lot of call drops in our situation where customer tried to contact their agents when they want to ask for help. In our system, we were using 2 data types to store information about time and dates. The first type was called timestamp, and the second type was called date time. In the eye of the inexperienced programmer, those types are very the same. But experienced MySQL programmers will know that those types differ very much. When MySQL will try to save a value into the timestamp column, it will try to convert this value from the current time zone to the UTC time zone, and after that it will store that value to the disk. When someone will try to read that value from the disk, MySQL will read a value in UTC, try to convert it to the current time zone, and then return the converted value to the caller. And to explain you some context, by current time zone, I mean the time zone that is set on a connection to the database. So it may be a time zone that is set on connection streak or explicit on a MySQL statement. Date times, on the other hand, are pretty stupid. MySQL doesn't really understand in what time zone the date time is, and because it doesn't understand that, it will assume that the value that it wants to save to the date time or read from the column that is the date time is always in a current time zone. To explain a little bit better, let's imagine that we have a time test table in a test database, and this table has 2 columns, one of the type date time and one of the type timestamp. And in this scenario, assume that we are in the same place when we are saving the data to the database and we are reading the data from the database. So the time zone between the save and the read doesn't change. After we try to read the value that we saved, you will notice that the red value are exactly the same as the value that we saved to that columns, even that those columns are 2 different times. And that is expected because we are in the same time zone, that doesn't change, so this value will be exactly the same. But let's imagine a slightly different scenario. In that scenario, we're still saving the same value to both columns, but when we are reading the values on the table, we switch our time zone to, for example, UTC +5, and ask a database server to fetch those values for us. If you can notice that the date time value is still the same as the value that we saved to the database, so it wasn't aligned to the current time zone, but the timestamp value was aligned to the UTC +5 column, and database server just added 5 hours to it because it noticed that we are in that time zone. And this was quite a big problem for us because most time zone specific data we kept in a date time column, which means that when the time zone shifts occurred, we lose the information what that date meant. And also not our web servers were not always in the same time zone. They usually change their time zones twice a year, which meant that even if we store the information in a timestamp column, twice a year we fetched a wrong date and some bad things were happening in our situation. Of course, we tried to fix the problem, and because we are working in a multi-tenant environment, we needed to do it in the following way. For each datetime column that we wanted to get rid of, we needed to add a new timestamp column. After we added a new timestamp column, we needed to start writing to those columns. And when all web servers were writing to that column, we can switch all the web servers to read from a newly added timestamp column. After some time where all web servers were reading from the new column, we could delete the datetime column. We even started to write a first line of codes. We wrote a first integration test and then noticed that we kind of found another trap. We proved to ourselves that we still doesn't understand how .NET and MySQL database engine is handling the time zone conversion. And to explain to you what was the problem, let me show you some code. This code is kind of a copy of the production code we have, but for the purpose of presentation, I removed a few things. First, it doesn't use any object relational mapping framework like Entity Framework or library like Dapper. And second, it doesn't use async programming that would fit here best, but it doesn't important for the purpose of that presentation. If you look at the code, you notice that those are two methods that are responsible for saving and reading some kind of the event to and from database. In the save method, you will notice that there is a very interesting SQL command that is set session time zone +0, and it was added to the test just to simulate that when we are saving, we are in a UTC +0 time zone. Similar code is in a getStat event, and it simulates that when we are reading the data from the database, we are in a UTC +2 time zone. That's not a production code, that is just the code that simulates that the save and the read happens when the time zone shift occurred. Okay, so this code is quite easy because the save just saves the datetime to the database, but before saving, it converts the value to the UTC. On the other hand, when we are reading the UTC value and convert it to the local value, but this is not shown on the screen because it doesn't fit here. Let's look at the test quickly. This test is very easy, and what it does, it prepares a stat event that you want to save. It prepares a datetime that is in a local time that we have to save. And after we prepare the data, we save the data to the database, extract the ID that was saved to the database, and then use that ID to retrieve the data from the database. The last line compares that the datetime that we received from the database is exactly the same that we saved. And this test for some reason was failing, and I couldn't really understand why. I assume that what is happening is that database receive a time that is in UTC and save it time to the disk. And when the client tries to read the time from the database server read the value from the disk and return the UTC value to the caller. But few of my friends explained to me that this is not what is happening here. Because what was really happening here is that when you were saving the stat event to the database, server received the value in UTC and just stored the value to the disk without doing any conversion. But when we requested the value from the database read the value from the disk, so that this value is in a UTC +0 and that the current time zone on a session is UTC +2. So done the conversion and add 2 hours to the value, and then the value was returned to the caller. The code that returned the value in the .NET also assumed that the received value is in the UTC, so it also done the conversion and add another 2 hours to that value. So instead of receiving the proper value in a local time, we received a value that was converted twice. One in a database, which added 2 hours, and the second time in the code, which also added 2 hours. So instead of having a value that was converted to UTC +2 time zone, we had a value that was converted to UTC +4. And we quickly fixed that issue by and forcing each session to be in a UTC time zone, which meant that the database server wouldn't do any conversion when it saved the value to the disk and when it read the value from the disk. But we also learned a few very important lessons. First, it's better to keep all your servers in UTC. Because if you are keeping your servers in a local time, then you have a lot of work ensuring that the date times that you are saving are in a proper time zone, and the date time that you are reading are also in the proper time zone. All that burden of keeping that information go away when you will keep all your web servers in a UTC. If for some reasons you can keep your server in a UTC time zone, you should at least enforce a session on your database that will save the time zone of the database to the UTC +0. That can be done either by setting that in a connection string or in a SQL statement that you are executing on database. And the third important bit, also very important from the perspective of the programmer, you need to test the corner cases in your software. In case of the software that operates on a date times, one of the most important integration tests that you need to write is that test that checks if your system behaves correctly when the time zone occurs. Because if you don't write those tests, sooner or later programmers will make mistakes and assume that the time zone change is not important for their scenario, which won't be true, because when you are working on a software that is delivered to the whole world, sooner or later the time zone change will affect your system. The last story that I would like to tell you is about how you can wrongly use the dependency injection technique in your code. And I think it's one of the most coolest stories that I ever heard and told to any people that I met. Few of our production web servers are more busier than usual. We notice that there is a high CPU overusage on them, and the rise of the CPU usage varies from 25% on a less busy servers to the 50% on a more busy servers. And during that time you have a lot of choices to make, and the best ones in our opinion were either to roll back the software to the version that we think is working, or either assume that this increase in CPU usage is related to the increased traffic that we had during that time, and just add additional web servers to which we will distribute the load to lower the CPU usage overall. And because it actually was a busy time for us, we decided to go with the second option and then went to sleep. But the next day, something worse happened. In addition to high CPU usage, we also noticed that few of our production web servers are eating memory like Cookie Monster cookies. Captain America would say that the situation is now pointing south and we need to react. At this point, we decided to roll back the software to the previous version, because we assumed that now the problem is with the code. And some battles better fought on the ground, you know very well, not on production. After some time of pretty heavy and long investigation, we found out very interesting class, well named, that could be somehow related with that problem. Be aware now, because what I will show you is really a production code that we have in our product, and it's called other methods. But don't be brutal for us, because you need to understand that the other methods are very legacy code that is probably older than any else of here. And it has so many methods to refactor that every programmer that tried to refactor those methods ended up in a mental hospital. So other programmers didn't try to even touch that. And what is interesting in that code is that it uses two kinds of the constructors. The first one, call it a proper one, takes 3 input parameters as a dependencies. The second constructor, call it bastard constructor, takes the 1 input as a parameter and creates 2 items in place. And one of the items that is created in that bastard constructor is a feature toggle service. It's a service-like object that holds the information about all the feature toggles we have in our software. And if you don't know what the feature toggle is, it's kind of flag that allows us to check if some specific paid feature is enabled for some specific customer. And because we had a lot of paid features and a lot of customers, we care deeply about having only few instances of that class in our system for all the web servers. And because now we are talking about this feature toggle service, let's quickly look at it. It also uses this painful pattern of having two constructors, one that is bastard constructor and one that is a proper one. But what was quite interesting for us is what is happening when this object was created. We are interested how many memory each of the instance of that object will steal when it will be created. We've done some measurements and we concluded that single instance of that class will use 30 bytes of the memory. So not terribly much. Usually in normal cases we don't notice such usage of the memory in our instances. But in our situation that was important. Because in our situation we had a bastard constructors and we couldn't control how the objects are created when a programmer will use that bastard constructor. In our scenario we have few clients that pretty heavily attacked our web servers. Each client executed around 200 calls per second and we have around 700 clients in that moment. So that's about 140 calls per second. Also not much if you look at how modern web servers or what load modern web servers can handle. But in our scenario, each call created a new instance of other methods, and new instance of other methods created a new instance of feature toggle service, and the new instance of feature toggle service reserves 30 bytes of the memory. Within 2 minutes, we ended up with so many feature toggle service that they end up about 3 gigabytes of the memory, which was almost the upper limit the service can allocate. And the service just restarted because of a lot of out-of-memory exception and kept repeating the process. The other backfire that we had during that scenario is that the memory was allocated so fastly and reclaimed also so fastly that the garbage collector couldn't keep up with releasing the memory that was allocated, and that was such high CPU usage. We tried to fix the problem as easy as we could because we wanted to deliver software to the production as fast as we could. And one of the workaround for us was to change the property to be static and read-only, which dropped the memory consumption from a few gigabytes per order services to 30 bytes per order services. The next stage that we are currently implementing is to get rid of those bastard constructors and get rid of those other methods. But there are some very important lessons that we learned here. The first lesson is that you need to understand the memory patterns in your application. You need to understand them because something that looks pretty small when you are looking at one class can be extremely huge when you will look at that class from the perspective of your whole system. So you need to profile your system and find those weak points and optimize them. The second important lesson is that if the data not change during the different instances of the object, there is no point of creating the same data for different objects. Instead, try to either cache its data or create only one instance of that data that is used by different services. And the last very important lesson is that you shouldn't use bastard injection. In modern software development, there is so many dependency injections that give you so many flexibility and control over the instance of the object that you are creating that you definitely can choose at least one that suits your use cases. Even in a language such old as C++, there is a movement that slowly creates some dependency injection framework that are usable in a C++. So there is no point in using the dependency injection, bastard injection in your code. And from my side, that is everything. Thank you for your attention. I'm really happy that I was able to talk to you all. I'm not sure if you have any time for a question, but you can always grab me for a coffee after this talk, and I will be glad to answer any question you have for me. Thank you.